In this setup, we see four LS1028A SoCs acting as switches for a TSN network unifying the wiring of multiple applications. Using time scheduling and frame preemption, one can run multiple industrial and custom protocols with real-time assurances. Here we see a range of different devices. One application is using Profinet with TSN scheduling to run a real-time application. The next is using an Office UA server to distribute data via TSN. A legacy application broadcasts Profinet RT in unscheduled transmissions. And finally, a custom setup uses the network to run a distributed motor control application. The motor control showcases our i.MX RT1170 crossover MCUs with integrated TSN MAC. We use a single i.MX RT1170 to run the motor control loops, whereas the motors are each addressed by a separate i.MX RT1170. Precise and stable control requires a network latency well below 250 microseconds, something TSN technology provides. Using an oscilloscope, we can see the signals corresponding to the different protocols right on the wire. Here we see the transmissions corresponding to the scheduled Profinet and Office UA traffic. The random blips coming through every now and then are the unscheduled Profinet RT traffic running on the same wire. We can now show how the Profinet signal disappears as we unplug the Ethernet cable running to the controller. As we plug the cable back in, the signal reappears in its previous time slot and traffic for the protocol resumes. Thus, we can show how different protocols and applications can be channeled over the same wiring using NXP products. Note that these do not use FPGAs. Instead, the TSN features are cost-effectively integrated into the SoC.